A cube with edges length 12 centimeters is built from centimeter cubes. This is 27. The faces of the large cube are painted. How many centimeter cubes will have 3 faces, 2 faces, 1 face, and no painted faces? So if you remember from your investigation yesterday or today, you had 8 cubes with 3 faces, the 8 corners really, and then the 2 faces along the edges. You had a linear relationship with the equation blocks was equal to 12e minus 24, and then 1 face. You had 6 faces of the entire cube, and inside each face you had n minus 2 side lengths. So you square that, you get the number of blocks that had 1 face painted. And then we had 0 faces painted, and we noticed there's just a smaller cube. There's actually a smaller cube that occurred to 2 cubes earlier in our little investigation. Therefore, n minus 2 is the edge length to the 3rd power's length, width, and height. So we have a 12 centimeter edge length, so we have to plug in 12 to our equations. So for 3 faces, it's just going to be 8, the 8 corners. For 2 faces, we have an edge length of 12. So we have 12 times 12, which is 144, minus 24, so it's 120. For 1 face, we plug it into our equation that we found in class. So we have 12 minus 2. 12 minus 2 is 10 squared. So that is 100 times 6 is 600. And no faces painted. Well, n is 12, so 12 minus 2 is 10 to the 3rd power, and 10 to the 10 squared is 100 times another 10 is 1,000. So it would be 1,000 blocks. 4 large cubes are built from centimeter cubes. The faces of each large cube are painted. Same deal, right? For question A, for cube A, 1,000 of the centimeter cubes have no painted faces. Well, we just did that, right? 0 painted faces. We got an answer of 1,000. So we know the edge length is going to be 12 centimeters. For B, cube B has 864 centimeter cubes with 1 face painted. So we're going to have to plug that in, right? And I'm going to actually go ahead and give myself some space, because I'm going to have to do some plugging in here, right? So I'm going to cover over this piece right here to provide myself with space to work. Well, I can put the 12 back, right? 12 centimeters. So we have 864 is equal to my equation for 1 painted face, 6 times n minus 2 squared. So the first thing we're going to do is divide by 6, because that is the opposite of multiplying by 6. So 864 divided by 6 is 144. That's a conveniently square number, right? Is equal to n minus 2 squared. What's the opposite of squaring? Well, taking the square root. So we have 12 is equal to n minus 2 plus 2 plus 2. 14 is equal to n. So it has a side length of 14 centimeters. For C, for cube C, 132 of the centimeter cubes have 2 faces painted, 2 faces. So same deal. We are going to So we plug it into our equation. So 132 is equal to, and this is 2 painted faces. So we have 12e minus 24. So add 24, add 24. So we get 156 is equal to 12e. Divide by 12, divide by 12, and e is equal to 13. Shocking, 144 plus 12. So that has an edge length of 13 centimeters. Lastly, we have cube D has 8 centimeter cubes that have 3 faces painted. Wait a second. All cubes that are made of centimeter cubes have 8 centimeters. I can't answer this question because all of them do. All right, 29, which goes off the cubes a little bit. All right. All right. So this is just a very basic thing, right? We're just plugging into the table, right? So that's easy enough. We're just squaring it. And here we're just cubing it, right? So it's just plugging it in. That's it. Okay, for each table, tell which column in the painted cubes table and problem has a similar pattern. All right, so this is a linear relationship, just like the two-face. Obviously has a slope of 1. This is a squared relationship, right? A quadratic relationship, just like the one-face. And this is a relationship dealing with something to the third power, cubic relationship. So therefore, this is going to mirror the 0 faces, because we have those cubes on the inside. So now 30. Consider the relationships described by these equations. Are any of them similar to the relationships in the painted cubes? All right. This is a linear relationship because there's nothing squared here. And that was just like the two faces. This is third power, so this relates to that, to the 0 faces painted, and this is squared, so it's the same thing. It's a quadratic because we have it squared, so that's one face. That's it. So we have 41 through 50. Okay, so here we go. 41. Where's 40? Oh, well. Okay, write each expression in factored form. So we just have to factor them. So first step of factoring is looking for a greatest common monomial. 2 does not go into 5, so no number. This doesn't have an x. So we know this is going to have a binomial pair of factors. Since I have a plus here and a plus here, each of them are going to be plus. And I have an x squared, so I know x times x. And I also know that 3 is a prime. So then the issue is, how do I get to 5? Well, I know that 3 plus 2 is 5, right? So I know that if I put a 2 here, 2 times 1 is 2x. 3 times x is 3x. It's equal to 5x. So it works. So here we look for a common monomial. Do I have something that goes into 4x squared and 9? The answer is no. So the next thing I look for a difference of squares. Is this a perfect square? Yeah. Is this a perfect square? Yeah. Is that a difference? It is. So this is a difference of squares. You know that a difference of squares will have one positive and one negative. Doesn't matter which one is which. And you just take the square root of each of these. The square root of 9 is 3. The square root of 2 is 2. X times x is x squared. All right. The next one, do we have a greatest common monomial? No, we don't, because 4 does not go into 9. And there's no x next to the 9. So therefore, I need to find a binomial pair of factors. And so, but wait a second. This could be a square binomial, right? Because 4x squared is a perfect square. 9 is a perfect square. So, what is the square root of 4x squared? Well, it's just 2x. What is the square root of 9? 3. Now, for this to be a square binomial, we have to have our a value and our b value multiplied together times 2. Remember that 2ab, that was a while ago, has to go in here. So, let's try it. 2 times a 2 times 3, 4 times 3 is 12. Did it work? It did! So this is the correct answer. Find the areas of these circles. Oh my goodness, I'm not going to go through and do this, but we know that area is equal to pi r squared, so we just plug it in. All right, copy and complete this table. Is the relationship between the radius quadratic? Well, here's the thing. Quadratic means it's taken to the second power. So it's going to be quadratic, and we know that, right? But they want us to just plug in the table, right? So I'm going to give my answers in pi. The area of this one is radius squared, which is 1. 1 squared is 1. So we have 1 times pi, which is pi. Here we have 4 pi, because 2 times 2 is 4. So this one here is going to be 9 pi, 16 pi, and this is x squared pi. So what's the difference here? 3. What's the difference here? 5. What's the difference here? 7. What's the difference here? What's the difference here? It's quadratic. Below are the nets, or flat patterns, for the surface area of 2 cylinders. Find the surface areas of the cylinders. All right, now here's the trick. This length here is going to wrap around this circle. So we know that this is actually the circumference. The circumference is pi d. So all you got to do is find the areas here, and you know the circumference. You multiply the circumference times the height, and you get it right there. But the trick here is to remember that this distance is the circumference. All right, D. Copy and complete the table. Is the relationship between the surface area and the radius quadratic? Well, here's the thing. Well, let's figure it out, shall we? All right, and I'm going to give my answers in pi again, because it makes more sense to do so. So the area of this is pi, the area of this is pi, the circumference is pi d, and the diameter of this is 2, right? So you have 2 pi times 2, which is 4 pi. So this is a total of 6 pi. So here we have 4 pi, and the diameter here is 4, right? So we have 4 pi. No. My goodness gracious. Diameter is, I wrote 2. My goodness. So that's 4. Sorry. So we have 4 plus 4, so that's 12 pi. I'm going to need more room. And so we have 1, 2, 3. So then for 3, make your shape. So this is 9 pi, because 3 squared is 9 pi. My diameter is 6 pi, and this is still 2. So this is 12 pi, right? And so 12 plus 18 is 30 pi. I have to do one more just to make sure. And then if this is using having a radius of 4, we'd have 16 pi. 16 pi. So this would have a circumference of 8 pi. So 8 times 2 is 16 pi. So 16 plus 16 plus 16 is 32. 32 plus 16 is 48. So here we go. What's the difference here? Well, 4 to 12 is a difference of 8. What's the difference here? From 12 to 30 is 18. From here to here is 18. So have I done something wrong here? 48. Just going to double check this one here. So I have 4. 2 times 2 is 4, right? So this one here also has 4 pi times 2. I forgot that. Times 2 is 8 pi. So that means 8 pi plus 4. Another 8 pi is 16 pi. My fault. I'm sorry about that. So then the difference from here to here is not 18. Oh, sorry, it is not 8. It is actually 12, right? So then from here to here is 18. What's the difference between 8 and 12? The difference is 4. What's the difference between those two? It is 6. So is our second difference the same? Apparently not. So it is not quadratic. Again, I apologize for the error. Come on, think about it. Multiple choice. The equation h is equal to 4 plus 63t minus 16t squared represents the height of a baseball in feet for t seconds after it's hit. How many seconds will it take for the ball to hit the ground? Well, what goes into all three of these? I can't tell you. I'm not exactly sure. Because 4 does not go into 63. So the question is, in a multiple choice question, this is going to be a hard one to factor because 4 does not go into 63. So there are a couple ways we could do this, but the easiest way for us, since this is multiple choice, is to plug in the numbers. So we know the initial velocity is 63. We know that that's going to make 15 seconds seem a little bit high, so I'm going to try 5 seconds. So we have 63 times 5. Let's try 63 times 5 is 315. So then we have 5 squared, which is 25, times 16. Plus well, apparently it's underground after 5 seconds, so that's not it. That obviously makes that not true. So let's try 4. So we have 4 plus 63 times 4 minus 16, 4 squared. 4 squared is 16, right? So we have negative 16 times 16. 63 times 4. 63 times 4 is 252 plus 4. 16 times 16, it's going to be 256. So we have 4 plus 252 minus 256. Oop, this is going to work out. So it will hit the ground after 4 seconds. Now this video is running long, so I'm going to stop it there, but there's a good start on your homework.